Let's take a look at this physics problem over here. We're given a spool of something that's like tied up very tightly, and it's got a total length of L. We want to find out how long it takes to unravel fully, assuming it's going on a plane of angle theta. Right, so what's going to be at play over here? Well, there's going to be rotational motion, and there's going to be particularly rolling motion, right? Because this is part of the problem statement. I didn't give the full thing yet, but imagine this is fastened over here. So then you know that it's not all going to slide down like this, right? It's going to just be unraveling, which tells us that there's no, that all the acceleration on the center of mass is going to be, well, actually, okay, so this is the formula, right? So we know that the angular acceleration times radius is going to be equal to the acceleration of the center of mass. This is what happens when you have pure rolling like we do over here. So let's actually relate that now. And let's begin by considering a little free body diagram. So this is our spool over here. Of course, we're going to have an acceleration of mg, a force of mg sine theta going down this way, right? And that's pretty typical in all of these sort of inclined problems. But we also have to consider the force of friction. And this comes up here, even though they didn't mention friction. We know that there has to be friction because that's what's going to give us the torque for the rolling motion. And that's what's going to allow it to have any rolling motion at all, right? So let's just call this F. Now we know that this is acting all the way on the bottom. We know this is acting on the center. So this is going to provide no torque. This is going to provide a torque of F times R. We know that that's going to be the moment of inertia times the angular acceleration. So FR is equal to, what is this? This is 1/2 mr squared alpha, right? Because it's a full ball. So that basically becomes like a filled cylinder, or what's it called, a filled disc, something like that, which is 1/2 mr squared. And I think I made a video explaining the derivation for that. Anyway, you can now cancel out the r's and you get F equals 1/2 ma because r alpha is a. What else do we have? We have mg sine theta minus F is equal to ma. So we can plug this in. We get mg sine theta is equal to 3/2 ma. Now, as you might expect, we can cancel out the m's, right? That's going to make it nice and easy for us. We get 2/3 g sine theta equals a. To figure out the total distance L now, we know that L is going to equal 1/2 at squared, which means 2L over a is equal to t squared. Now, all that's have to do is actually go ahead and plug this in. So it's going to be 2L over what? Over 2/3 g sine theta. And this becomes nothing but 3L over g sine theta. And now, of course, we have to take the square root of that. And that becomes the final answer. Hope you learned.